Okay, I will start this then. So, hello everyone, and welcome to the 44th DevOps Porto Meetup, where we are all about the DevOps values, practices, and culture. Today, I will be hosting the event. So, you can find us on our website, Twitter, our Slack, Gmail, and also we have a YouTube channel. For these pandemic times, we have set some online guidelines that we wish you will follow. Basically, when you join, you should mute yourself. We ask you to rename yourself to your name and with city and location. And also you can turn on your webcam so we can see each other's faces. After the presentation, there will be questions and answers. You can write your question in the Zoom chat and the host will read it later. Or also you can use the raise hand function of Zoom. After the presentation, if you want to keep the discussion going, you can go to our Slack. There's a link for you to join. So today, we have Mete Atamel, and he will be talking about choreography versus orchestration in serverless microservices. All right. You can start sharing.
Okay, so let me share my screen. So let me know when you see my slides. It's okay?
Fine.
All right, cool. All right, well, hello everyone. First of all, thanks for being here. I know I'm always amazed when people spend their evening learning things in a meetup. So I'm always grateful for that. So thanks very much. And today's topic is not strictly DevOps per se, because I'm going to be talking about how to deploy microservices using orchestration and what are basically the pros and cons of orchestration. And as I do that, I will contrast that with choreography. So it's more about how do you structure your microservices, but at the same time, I think it's still relevant to DevOps in the sense that, you need to understand your architecture, you need to understand how things work, and you need to understand the trends like choreography and orchestration, so that when you're designing the next system, you keep this in mind. Before I start my talk, feel free to stop me and ask me questions along the way. I actually like to have interactive sessions, so feel free to ask them if you want as we go along. And also, if you post something in the chat, maybe someone can let me know, because I don't know how to check the chat right now. But if someone posts something in the chat, let me know, read it to me, and then I will be happy to answer as we go along. But we can also have a Q&A session at the end as well. I should also mention that I have these slides on speaker deck in this link that I have. So feel free to get the slides afterwards if you find it interesting. And I'm going to show a demo app towards the end of the talk. And that demo app is also open source and it's on GitHub. So I'm going to share the link of that at the end of the presentation as well. So everything I show here and I talk about, it is available. It will be available to you if you want to learn more later. All right. So the way this talk is going to go is that first I want to describe to you what I mean by choreography, what I mean by orchestration at the high level, so that we have the context. Then I want to look into the orchestration landscape. The choreography and orchestration landscape a little bit. So I want to talk about the tools and the services in different clouds for choreography and orchestration. Then I want to zoom into orchestration a little bit more, because choreography, also known as event-driven architectures, they're kind of known for a while, and people usually understand them, and we know the tools around them. But orchestration is something new, so I want to zoom into that a little bit more, and I want to talk about Google Cloud's orchestration service workflows a little bit in a little bit detail, just to give you an idea of what kind of things an orchestrator can do for you. And then finally, once we have all the background information on orchestration and the concrete tools, I want to look at a case study. One app that me and one of my coworkers, we wrote with Choreography first, because that's what we knew at first. And then we rewrote it once we learned about orchestration and how that looked like and what we learned along the way. So I think this is the most useful part of the talk, because it's kind of real world, and it has the lessons learned as well. So I want to kind of bring it all together with that application towards the end. All right. So with that agenda, so let's first talk about choreography versus orchestration. What do we actually mean by this? And I want to talk through this through a simple application. Let's imagine that you want to build a simple e-commerce application. And as you know, in e-commerce applications, typically the idea is that you receive some order, you charge the user for that order, then you prepare the item to ship, and then you notify the user that the item is shipped. In a nutshell, and this is what happens. Of course, in places like Amazon or other places, things are much more complicated. But when you break it down to what an e-commerce application is, it's basically order requests, right? So how do you design that kind of a system? Well, one way of designing that system, as we used to do in the old days, is that you can put all of these services together in a single monolith and deploy that monolith as a single application. And it will work for sure, but it will have a lot of problems, the monolith problems. And I won't go through the details of what those problems are. I think people at this point, they understand what a monolith is and why it's not the best way of deploying applications. So you probably don't want to do that. Instead, you probably want to deploy multiple microservices that do certain focus things, or the certain focus parts of an e-commerce transaction. So in an e-commerce transaction, you need to receive an order. You need to receive an order through a front end. So you probably need a front end. So you have probably a microservice that handles the request coming in. Then you probably want to have a microservice to do the payment processing, so authorizing the credit card and then charging the credit card. Then you want to do some kind of work for shipping the item, because shipping the item probably involves multiple steps, so you probably have a separate function for that. And then finally, once all of that is done, you want to probably let the user know that the item is shipped, so maybe you have another service for that. And on Google Cloud, there are different services for doing these things. So typically, App Engine is the front end for web applications. Then for running serverless kind of services, you have Cloud Functions for functions, and then you have Cloud Run for containers. So maybe for payment processor, you have a container to handle that, so you run that on Cloud Run. And then maybe shipper can be done within a Cloud Function. And maybe notifier is done via SendGrid, an external service, but maybe you're calling that external service through a container again. So that's why it's in a Cloud Run. So in this model, you have 4 microservices doing their part. And these microservices, they call each other directly. You can actually hard code their dependencies per se. So you can have the front end to know about the payment processor. You can have the payment processor know about the shipper, and so on and so forth, right? So this is one way of doing this transaction. Now, in this model, I call it the simple REST. So you're basically just doing, you're receiving a request, and then you're just calling the next service in the chain. So you're just doing simple REST calls. And the pros and cons of this approach is that, the pros is that, you divided your application into multiple microservices that do, a certain part of the transaction. So that's already good. You are dealing with microservices. You're not dealing with a single monolithic kind of application. And this model is also easy to implement, because services, they run independently, and they just know about the next service in the chain, and they call the next service in the chain directly. So it's easy to implement. You don't need to worry about things like service discovery or messaging, things like that. It's basically just a service calling the next service in the chain. On the other hand, the cons is that you already have too much coupling between the services, right? Because each service, it has to know about the next service in the chain. So you're already kind of baking that coupling into your architecture. And that's not good if you want to have a flexible kind of architecture. Similarly, each service can be a single point of failure because, what happens, for example, if the payment processor fails in the middle, what do? I mean, you need to handle it somehow, and it could break the whole chain if you don't handle it. Similarly, each service needs its own, error handling. It needs its own retry logic. It needs its own timeout logic, right? I mean, in an ideal world, you make a call from a service to the next service and everything works, and it will probably work 90% of the time. But when things don't work, what do? What do you retry? When you receive an error, what do? Do you retry on that error, or do you propagate that error to the user? So all these policies, you need to handle them in each service, either separately or in a global way somehow. And for me, the most important thing that's being overlooked here is that who ensures that the whole transaction is successful? Each service itself can kind of make sure that their work is done, but who actually makes sure that the whole transaction is successful? And if one service fails, for example, who makes sure that that service gets called again, right? So all these questions you need to kind of answer in the real world. Now, what you can do is to kind of handle these cons is that you can start using an event-driven kind of architecture to get rid of some of these problems. In an event-driven architecture, you still receive the request in the front end, so the order comes to the front end. But instead of front end calling the next service in the chain, what it can do is it can send a message to a message broker. Message broker, it's a messaging system, and many cloud providers, they have different kind of message brokers. You can also use something like Kafka if you're in open source world. So basically, you have some kind of messaging system that kind of sits in the background and expects to receive messages, and then it expects to send messages to other services. So the front end receives the request, then it says, okay, I received this request. This is the context of the request. And it can send an order received kind of message to the broker. Then the broker knows that the payment processor will be interested in handling this order, right? We need to first charge the user. So it will route this message to the payment processor. Then payment processor will receive that message. Then it will do its work. Then it will emit this payment process kind of message. And then the whole chain continues. Now here, still the things happen in the order like before, but they happen much more flexibly, right? Because you are not having services calling each other directly. You are having services emitting messages when they finish their work. So the order is received, payment is processed, the item is shipped, things like that. And then the service who is interested in that event will receive that message and it will act on it, right? So this allows a much more flexible kind of environment where you have services come and go, and then services can be plugged in as you need them, and they only respond to the messages that they need to respond. And for the rest of the messages that they don't receive them, they don't care about them. Now, what are the pros and cons of this? And this is, by the way, this is called event-driven architecture, also known as choreography. And the reason for that is because each service is basically, they're doing their own kind of thing, right? That's why it's called choreography. They're basically handling the messages they care, and they're emitting the messages that that they want to emit when they want to signal to other services. Now, this works for simple use cases like this one, where you have a few services, but a real e-commerce transaction is usually much more complex. Someone has a question? I hear some background noise. No? Okay. So in a real world e-commerce transaction is much more complicated, right? It's not just a number of services calling each other in a simple order. Instead, you probably have a combination of services calling each other, and also a combination of, calling your DB, calling external services, things like that. So for example, in this case, we start the transaction, we check our database, whether we have the inventory, and then if we have the inventory, so we have a decision tree, then if we have the inventory, then we go and prepare the order, and we update our inventory again, and we notify the customer. And then if you don't have the inventory, then we might want to make a call to an external API, to the supplier's API, order this thing that the user wanted, and then prepare a different message, and then update our inventory again. So you have this kind of systems in the real world. Imagine doing this in an event-driven way, right? Imagine you have services that are sending and receiving messages, and you're trying to implement this flowchart in the event-driven way. It is possible, but it's not that straightforward. How do you take this flowchart and how do you implement it in an event-driven way with services within your cluster, but also with services that are external to your cluster? And also, the key thing here is that you want to make sure this transaction is actually happening the right way, right? Who actually makes sure of that, right? So the pros and cons of choreography is that, first of all, in event-driven architectures, services are loosely coupled, which is a good thing because you can change your architecture much more easily. The services can be changed independently, they can be scaled independently, and that's what you want from a flexible architecture. So those are good things. You don't have a single point of failure in the sense that, if a service, for example, stops working, it won't process certain messages, but the rest of the services will still, receive and send messages. So in a way, your system will still work. Maybe it won't work fully, but it will work at some level, right? So your whole system won't stop. It's not like a single chain that stops because something fails. Some parts won't work because some service doesn't work, but the rest of the services that can receive and send messages, they will still work. So that's still a little bit better. Not that much better, but it's still a little bit better. And also, in general, the events, they're useful to extend your system. So if you want to extend your system, add new services, then all you need to do is just, add that service, and then specify what kind of messages it's interested in and what kind of messages it can emit, and that's it. You can easily extend your system by adding new event types and new services. On the other hand, the cons is still there. It's with event-driven systems, it's difficult to monitor the whole system because you have all these services there emitting all sorts of messages, sometimes multiple messages, multiple event types, and it's hard to monitor them and make sure that things are happening correctly. Because let's say some service doesn't emit a message, or maybe it's supposed to emit like 2 messages, but it emits 1 message. How do you catch that? It becomes much more difficult. Similarly, if you want to apply errors and retries and timeouts, that's still a problem that you need to think about. This business flow, like this flow chart that I showed you, right? The flow chart is very nice and it's very clear. Like when you look at it, you know exactly how the business process is supposed to work. But how do you capture that in an event-driven system? It's not captured anywhere. You can't really point to a place in your system and say, this is how the business logic is. The event-driven system will do the right thing if you design it the right way, but it's almost like a side effect, right? There's no central place you can point to for business logic. And finally, we still have this problem of the whole transaction, right? Who ensures that the whole transaction is successful? That's still something that you need to worry about, and someone, you or some other service, has to make sure that the whole transaction is actually successful. So the problem that we had before is still actually there, even though things are much more flexible. So we have a more flexible system with the same problems. Now that's when orchestration comes into play. So if we go back to our simple e-commerce transaction and try to orchestrate it, the way we could orchestrate is could be something like this. So you have the front end still receiving the requests, and then instead of calling the next service in the chain, or instead of sending a message to the message broker, what it can do is it can kick off an orchestration. And this orchestration is basically done by an external orchestrator. So there's an external orchestrator service that has an orchestration definition. And the front end can say, okay, kick off this orchestration, and orchestrator will say, okay, I'm going to kick off the e-commerce transaction. And orchestrator has this definition that says, okay, first call the payment processor. Once that's done, call the shipper. Once that's done, call the notifier. So the orchestrator will be the one in charge of calling these services in the order that you define and with the parameters that you define, right? So in this model, you still have the services being called in the order that you want, but that call doesn't happen in a chain. It doesn't happen in an event-driven way. It just happens through an external orchestrator that you define, that I will talk about when I talk about it in workflows. Now, the pros and cons of this approach is that, first of all, since you are defining this orchestration, also known as workflow, you can capture this business flow, right? The flow chart that I showed you before, you can actually capture that in a definition, in a workflow definition. And this is very important because, once you capture the business flow, that business flow can be source controlled and can be updated and can be versioned. So there's a lot of benefit in actually capturing this and source controlling it. So that's a big benefit already. Secondly, you have these steps in the orchestration, and each step can be monitored by the orchestrator. So you can see when each step is being called, and you can see if each step was successful or not. You can have error, retry, and timeout logic applied centrally. So in the orchestrator, you can define and you can say, if I receive these kind of errors, do this, retry this many times. Or you can define things like, if I make a call, wait this much time before you time out. So you can do those on a step-by-step basis. Like, so for each step, you can define them in a custom way, but you can also do them in a centralized way. And usually you want to do these kind of things in a central way because, if you call services, you probably have a central kind of policy on how much you want to wait. So all those things can be centralized. And in orchestrators, you can still stick with simple REST calls. So your services can still stay in simple, plain HTTP REST without having to deal with eventing and different event types. And because they can stay in that, an orchestrator can use that as simple REST calls to make calls to your services. So you don't need to deal with eventing at all. And finally, the services, they're still independent. They can still run independently. They can still be scaled independently, deployed independently, all that kind of stuff, except they're kind of brought together with the orchestrator, right? The orchestrator kind of brings them together, defines how they're run together in one order. But the services themselves, they're still independent, which is a really useful thing to have. You don't want to create another monolith with an orchestrator, right? You want to keep things separate as much as possible, but also have this structure that comes with the orchestrator. Now, on the other hand, not everything is perfect with orchestrators. So an orchestrator, it's a service, just like any other service, that you need to learn about and you need to worry about. So it's something that you need to take into account. Orchestrator can be a single point of failure because everything happens through the orchestrator. So if you don't choose a good orchestrator, then you might be out of luck. So you need to make sure that the orchestrator that you're using, it's highly available and highly scalable, and all the things that you want from a reliable orchestrator. So make sure that you have that with the orchestrator that you're using. And since you're relying on REST calls and your services are using REST, arguably you have more tight coupling compared to eventing, because in eventing, things are really flexible. It's very easy to add and remove things in an eventing system. Whereas in an orchestrator, you need to, I mean, you still can add services quite easily, but it's not as easy as, just here's a new service and this is the event type that it expects. You need to deploy the service, and you need to change the orchestrator definition, and you need to specify, okay, after this step, include this new service, and this service gets these inputs and things like that. So it's a little bit more involved than an event-driven kind of service. All right, so this is kind of a quick summary of what is choreography, what is orchestration, and what I mean by them. And at this point, you might be wondering, okay, which one is better? What do I use? When do I use which one? And I think the question is, it really depends. Like, there's no really, there's not a single answer on like choreography is always better or orchestration is always better. It really depends on what you are trying to do, and it depends on your use case. So there's use cases that are better for choreography, and there's use cases that are better for orchestration. Now, in general, what I think is that if you have services that are not really closely related, they're like independent services. They usually live independently, and they can go in different orders. Usually, they don't have to go in certain order. So for those kind of services, I think choreography is better, and event-driven system is better, because these services, they are not really close to each other. They don't need to call each other in a certain order. So for those kind of use cases, you probably want to think about choreography or event-driven. Also, if your services, they can exist in different contexts. What I mean by that is that, for example, if you have a notification service, for example, it can live in a e-commerce checkout process, because you want to let people know that your checkout is done and you want to notify the users. But maybe the same notification service can live in some kind of other process where maybe your service fails, and then when it fails, you want to notify the admin that the service failed, right? In a DevOps kind of context. So it's the same notification service with different contexts. If you have that, and if this service is going to live in different contexts, and it will be called in different orders and from different services, then maybe an event-driven architecture is better, because it will be much easier to plug that service as you need it in different contexts. Now, at the same time, if you have a business logic that you can clearly define in a flow chart, right? If this happens, I do this, then I talk to the database, then I do that, that kind of thing, then that is a prime target for orchestration, because you can define the business logic, and services are called in a certain order, and you want to be able to apply global retry policies and things like that. So in that kind of context, you need to start thinking about orchestration, because you don't need the flexibility of event-driven systems at that point, right? I mean, you really want this flowchart, and you want to make sure this flowchart is actually executed in that order and executed fully, right? So all the flexibility of eventing doesn't apply anymore. So that's the point when you should start thinking about orchestration. And also, if the services that you're dealing with, they're always related somehow, they always go together, they're always deployed together, they always call each other in a certain order. If that's the case, then maybe it makes sense to put them in orchestration. I mean, again, I think it's still useful to have services to be independent as much as possible, because if they're doing different things, keep them separate. But if they go together, deploy together, then an orchestration might make sense. And I also see people using orchestration because they want to stay in REST HTTP calls. They don't want to deal with eventing. And the reason for that is that eventing, even though it gives you flexibility, it also gives you a lot of complexity, because with eventing, you need to deal with multiple topics. You need to deal with multiple different event types. Then because event types and event formats are quite flexible, then you need to worry about how do you parse those events. So there's a lot of complexity that comes with that flexibility, and people don't want to deal with it. They want to deal with plain HTTP calls there that everyone understands. So if that's the case, then orchestration might be a good case, because orchestration deals usually with just plain HTTP calls. And you can also have a hybrid approach, right? So if you have services that are closely bounded together, put them in orchestration. Then if at the end of the orchestration, maybe you want to let the next bounded context to let know that, I'm done with my thing in an orchestration, and you signal others that, with a message that I'm done, you can do the rest, right? So in this model, you have the hybrid approach where you have the bounded context, the services in a bounded context and orchestration, and they communicate with the other ones using messages. So it doesn't have to be either or, basically. It depends on your use case. You can choose one or the other, or you can combine them in a hybrid kind of architecture. All right, so that hopefully covers what I mean by choreography and orchestration, and when it makes sense to use one or the other or both. Now, to look at the landscape here a little bit. So when we look at event-driven architectures, on AWS, you have products like SQS, EventBridge, SNS. On Azure, one of the ones that I always hear is EventGrid for eventing. On Google Cloud, we have PubSub that's been around for a long time, and we have something new called EventArc for sending events from different sources to Cloud Run. And then there are open source projects like Kafka and others for eventing. So this is kind of the landscape, and I'm sure there's much more than this. But just to give you an idea of some of the names, these are basically the main names that I could find when it comes to kind of tools. Now, in terms of orchestration, on AWS there's step functions, and then on Azure there's logic apps, which is kind of like step functions, but it also has some logic on top of them. And then on Google Cloud, there's workflows and Cloud Composer. Workflows is more about orchestrating services. So if you have services running on App Engine or Cloud Functions, Cloud Run, you can use workflows to orchestrate them. And then Cloud Composer is more about orchestrating data pipelines. So if you want to do big data processing, then Cloud Composer helps for orchestrating that. And then there's open source project Airflow that Cloud Composer is based on. It's also mostly for big data processing. So there's also tools in this space as well. What I want to talk about now is workflows, because that's what I know mostly for Google Cloud. And my point here is that I want to show you what a service like workflows can provide. What a service like workflows can provide when it comes to orchestration. So what can you expect from a service like workflows when it comes to orchestration? Before we get into workflows, I should also mention that there's an open source CNCF serverless workflow specification that's being worked on. It's a sandbox level project last time I checked, and it tries to define a specification basically for defining workflows. I don't know what's the latest status. I haven't checked it for a while, but basically at some point this will be final, and it will be a way to define workflows in a standard way. Right now, I don't think any of cloud providers like Step Functions or Google Cloud Workflows or others, they don't implement this specification, I don't think. But at some point when this becomes final, I think it will be interesting to watch, see what happens, because it would be interesting to basically define a workflow, let's say on one cloud, and then using this, and then deploy that to another cloud, or maybe run it locally as well. So this is something to watch as well. So there's a lot of things happening in this orchestration space. All right, so now let's talk about Google Cloud Workflows and see what kind of things it provides us for orchestration. And then after I finish this, I want to talk about the case study and finish with the case study and let you know what we learned from that case study when it comes to orchestration. So Google Cloud Workflows, what is it? It's a service. It's a cloud service that lets you orchestrate and integrate different services. So it lets you orchestrate Google Cloud services. So if you have code running in Google Cloud on, say, App Engine or Cloud Functions or Cloud Run, you can use workflows to orchestrate them, to call them in the order that you want. It also lets you orchestrate Google APIs. So if you want to call a Google API, like Google Cloud Vision API or Gmail or others, so any kind of Google API that understands HTTP, you can include them in your orchestration. and also external APIs. So if you have an external API that you want to call, like SendGrid or any kind of HTTP kind of API, you can include that in your workflow too. And for me, this is very important because when you do things in the cloud, or actually when you do any kind of software nowadays, it's not about just your code, right? Usually you do something in your code, then maybe you call an API within your cluster or something like that. Then maybe you want to call something external and do something else, right? So it's never just about your code, but workflows allows you to include all of those into your definition of your workflow. And I think this really helps to make sure that you can use basically whatever you want in your workflow. Now, in terms of how you define your workflow, you have a YAML or JSON syntax. So that's how you define your workflow. And then you have this step. So in our example, we had this payment processor, shipper, and notifier running on Cloud Run, Cloud Functions, and Cloud Run. What you can do is you can create steps for these in your definition. So you have a step called process payment, another step for ship items, another step for notify users. So 3 steps. And in these steps, you define how to call these services. So the call is an HTTP post here in this case, and the argument defines how you make this call. So the URL it's a Cloud Run URL, and the body is this body that I received from the previous step. So I receive this body from the previous step, and I pass into my HTTP call. Then the result of this call, we capture that in a variable called process result. So we get this result, and then we pass it to the next step. So in this next step, we are making an HTTP post again, but this time we are calling a cloud function. So it's a different part of Google Cloud. It's not Cloud Run, it's Cloud Function. And then we are passing in the result of the process result, the body of that, as the input. Right, so you get the idea here that you basically make the calls, so you get the results, and then you pass the results to the next steps, and so on and so forth. Now, in terms of steps, you can regular steps. One service calls the next service in a certain order, so you can define it in the YAML. You can do serverless pause. So, for example, let's say you process the payment, you ship the item, but before you let the user know, you want to wait for, say, like an hour to let the user know. So you can add a pause between your steps in workflows, and the workflows will pause, and you can pause as long as you want, and then make the next step call. And then it has this JSON parsing between steps. So when you make a call to a service, you receive a result. You can parse that result within this YAML. So you don't have to actually write code to parse it. You can get the result of the body and look at the first person in the body, and then get the first name of the person, things like that. And then you can pass those results in the next step. This is very useful because usually you need to write code for this. You need to deploy code to parse the result and then call something else. But with workflows, you don't have to do that. It has that intelligence built in already. It's limited though, so you can't do everything. But for most things you can do, and it can save you a lot of code basically. It also have errors and retries. So for example, you can say, if I call payment processor in my step, and if it fails, I want to try maximum 5 times. And then I want to do this in an exponential backoff kind of way. So that's my policy to apply. So you can define this per step, but you can also define it globally, so that this applies to every single step. It also has this branching with errors. So you can say, for example, if the shipper fails with HTTP whatever error, then you can send it to one service. But then if it is successful with HTTP 200 whatever, then you can send it to another service. So you can do that kind of conditional logic very easily in workflows. And finally, you can actually check things within workflows. So for example, if you are reading an inventory from your database, you can call the database directly from workflows if the database supports HTTP calls. And you can get the result from the database. And then you can check the stock, whether you have the stock or not, or a certain value. within workflows. So you don't have to write code for this. And then depending on the value, so if it's less than 0, you can do certain things. And if it's more than 0, you can do certain things. And then you can make calls to external APIs. So the HTTP calls, they don't have to be within Google Cloud. They can go outside and come back as well, which is really useful. And to wrap it up, you can also have sub workflows, meaning let's say you do certain things all the time. You can put them in a sub workflow. It's kind of like a method call, basically. It's like creating a method in code, but instead you create a sub workflow, and then you can use this sub workflow from multiple places. And workflow also has these things called connectors that helps you to make calls to Google Cloud services in an easier way. So let's say you want to make a call to a PubSub message. You want to send a PubSub message from a workflow step. You can use this PubSub workflow, and it basically, instead of you creating an HTTP call, this connector creates that HTTP call for you. And the syntax is much easier, and it has intelligence for retries and timeouts. So basically, if you want to make a Google Cloud calls within workflows, use these connectors because it's much easier to deal with. And to deploy a workflow from command line, you can just say gcloud workflows deploy, give it your workflow a name, and then point to your source, which is in YAML or can be in JSON as well. Then once it's deployed, you can execute the workflow, gcloud workflows execute, and this will run the workflow. And then you can see the workflow as it's running. So you can say workflows executions describe, give your execution ID, and then your workflow ID as well. And then this will display the result of your workflow. Of course, all of this stuff is also in UI. So if you go to Google Cloud Console, you can see the source of your workflow. You can see a visualization of your workflow. So it's not so that the flowchart that I mentioned, you can see it actually and then you can execute the workflow here, see the logs and all that kind of stuff, which is really useful. All right, so this is Google Cloud Workflows. So finally, let's talk about the actual case study that I want to talk about. So this case study, it's an app called Piccadilly. Me and my coworker, we wrote this application. It's a picture sharing application. We wrote it initially as a prototype for a customer, just to show Google Cloud technologies to a customer. And the idea of this application is that, let me show you here. Yeah. So this application, and by the way, this is the link of this application. Once we wrote it, we also created a workshop around this. And you can actually build this application yourself if you're interested. And this is the link, and I will share the link at the end of the presentation as well. But the whole idea of this application is that you upload some pictures that you have, and then this application will analyze the picture. And first of all, it will look at the picture, and it will extract the labels of this picture. So you can see under each picture, we have some labels about what the picture is about. So this is a dish, food, cuisine, things like that. This is done using machine learning. We use a vision API to extract these labels. And also you see a border around this picture. That's the dominant color in the picture, again, extracted by machine learning. So you upload the picture, then the picture is analyzed. And once it's analyzed, we figure out the labels and the borders, and we display them. And we also, I don't show it here, but under collage, we look at the 4 latest pictures and create a collage out of this picture. So it's a simple image sharing application, but we built it just to show Google Cloud technologies. And the architecture that we used initially was it was a choreography architecture. It was an event-driven architecture. And the way it worked was brief. Just to describe it briefly, was like this. So the user upload the picture to a front end running on App Engine. And this picture will go to a cloud storage bucket. So we have a pictures bucket. And then once the picture lands there, that will trigger a number of messages. So the first message will go to an image analysis function. It's a cloud function that will analyze the picture using Vision API. And it will get the metadata about the picture, and it will save it into Cloud Firestore. Then the second event will go to PubSub, and from PubSub it will go to a Cloud Run service called Thumbnail service, and this service will resize the image because the images are different sizes. So we want to resize them into a smaller size, and it will save that image to a different bucket, and it will also save that metadata of the image to Firestore. Then we had a collage service that will be triggered on a schedule. Every minute, it will go and fetch the thumbnails of these four most recent pictures, and it will create a collage out of those images. And then finally, we also had a fourth service called image garbage collector, which triggered when someone deleted a picture. So if someone deletes a picture, it will trigger an event. This time, this event will go through event arc, a different eventing infrastructure, and it will get to image garbage collector service. And this service will delete the image thumbnail, and it will delete the metadata of the service. So it will just do a cleanup of the image. So as you can see, this is a very event-driven kind of architecture, right? An image is saved, and that kind of triggers multiple events. And these are different events. These are different events. This is a Google Cloud Function event. This is a Google Cloud Pops Up event, and this is an event arc cloud event, which is a different format. So we had three different event formats that are triggered. And even though it's a simple application with not so many kind of services, we were already kind of struggling to make sense of this architecture because sometimes things wouldn't work. Like sometimes, for example, we wouldn't see an image, and we would be kind of wondering like what failed, and we had to basically start looking one by one in each service log to see if something failed, right? So all the problems that I talked about, event-driven architectures, we started having them in this architecture. Kind of like tracing where things failed, looking at the logs all the time when things failed. And then when things failed, it kind of broke the whole chain and we didn't know where it broke, things like that. So when workflows came along, and this was at the beginning, so we wrote this application last year, and at the beginning of this year, workflows became GA. So when it became GA, we said, okay, can we take this application and can we make it more like an orchestration? Because in this case, we actually know how things are supposed to work, right? When user uploads a picture, we know how the order of things that should happen. I mean, we don't need this flexibility of event-driven architectures. So what we did is we rewrote this in using workflows, and the way it looks is like this. So we still have the front end that receives the images, and then it goes to the bucket, just like before. And then this triggers an event from the bucket to a cloud function. So it's still event-driven in that sense. Just one event when the picture is saved or deleted. And then this cloud function, instead of emitting more events or doing other things, it basically triggers a workflow. So this flow chart is actually a workflow definition, right? And what happens in here is that the workflow starts, then the workflow checks the event type. Is this an image creation event, or is this an image deletion event? If it's an image creation event, object finalize, then it does image analysis using Vision API. So it makes a call to the Vision API directly. We don't need to write code for this. It's done in workflows. Then it transforms the data that it receives from workflows. Then it checks if the image is safe, again, using Vision API. Then it stores the metadata to Firestore, again, without needing to write code. And then it makes the calls to thumbnail service and the Cloud Run service, right? So in these steps, it's making calls to existing Cloud Run services. So this is still kind of the same. Now, if the image is deleted, then it does the thumbnail deletion and Firestore deletion, again, within the workflow. So you can see that in this model, you have kind of like a combination of workflows doing the work. So some of the work is done within the workflow, and some of the work is done by delegating to the external services. So Cloud Run, for example, thumbnail service and collage service, that's when the work is delegated, right? But we saved a lot of code by doing certain things within workflow. And actually, let me show you this quickly here. I'm in Google Cloud now, actually. So I just want to quickly show you this. And if I go here and if I go to workflows, you can see that I have this Piccadilly workflows. And then you can see that these are executions that I did. So you can see I tested this earlier today or yesterday. And you can see the logs and details and source. But if you look at the source, for example, the source is the definition of the workflow. So this is the definition. These are the steps. So we have the initialization step. We have the event type switch, meaning this is the step we decide what kind of event is this. So we can do things like conditions here, for example, to check the event type. Then if for example, if the event type is object finalized, then we do image analysis call. If it is something else, we do picture garbage collection. And then in the image analysis call, you can see that we are making a call to the Vision API directly with the request. Then we are making a call to transform image analysis data. This is a cloud function, and so on and so forth. I mean, I won't go through in detail, but you get the idea. And then we get this visualization where you can see what's happening. You can see the event type switch. You can see when things are called, stuff like that. And actually, if I go to the application, let's just go look at the application quickly. So this is an App Engine front end. So let me just see the URL. So let's just open this. You can see I have this app with some images that are already there. But if I upload an image, let's see if I can upload an image here. Let's upload a picture of myself. And then hit submit. Now this is being submitted. And if we go to workflows, we should see a new execution. So you can see this execution is active. It's running right now. So this triggered a workflow run. And once this is done, now it succeeded. It's already done. You can see the input that it received. And the output is what we outputted in our workflow. So the output is basically the HTTP code, HTTP result of each service. So the collage service return 204, image analysis, store metadata, and thumbnail return 200s and 204. So you can easily see if something is succeeded or not. If something failed, you can easily see it from here, which is really useful. And if we actually go back to our application and do a refresh, we should see my picture is already labeled with the metadata and all that kind of stuff. So workflows makes it really easy to kind of put these things together. So what we learned here, I want to wrap up now because I think we are running out of time. What we learned here, and I think this is kind of the main points that I want to make for this talk, is that first of all, when we switch from event-driven to orchestration in our Picadilly application, we went from 3 different eventing formats with Cloud Functions, PubSub, and Event Arc, and passing those in all these services to simple HTTP calls. And this was really refreshing because we got rid of a bunch of code that we don't need anymore. It was a single format. It was very simple to understand. And we could call these services directly ourselves, but we could also call it from Orchestrator as well. And that was really refreshing. We got rid of a bunch of code. So we don't have to parse events. We don't have to do image analysis in a function because workflows can do that for us. We don't have to do garbage collector service because workflows can clean things for us. So we got rid of a bunch of code because of workflows, which was good. We got rid of a bunch of setup because we don't need to use PubSub. We don't need to use scheduler. We don't need to use Event Arc. So because of that, we don't need to set these services up. We need to set Orchestrator. So the workflows we need to set. But we kind of traded 3 setups with one service, which is for me, it's a win. Instead of dealing with 3 different things, I rather deal with one thing. It's much easier for me. And error handling became really easy because we could immediately see if something fails, in which step it failed, and then we can immediately zoom into that step which has the service call, right? We don't have to look for logs anymore. We don't have to figure out like why things failed, where they failed. Workflows would tell us immediately which step failed, which is a big win for us. Now, on the other hand, not everything is perfect. So workflows, it's a new service to learn with its quirks and limitations. So you have to get used to it, as in any kind of new technology. As I mentioned, we got rid of well, a lot of code with workflows, which is good, but you had to convert that code into YAML definitions, right? Because you had to do them in workflow, so you had to define them in workflow. So it's an open question, like which one is better? Is it better to deploy a service with code that you can unit test and you can understand, or convert the code into YAML, which is painful. I don't think YAML is designed to do a lot of code, but that's what you're basically doing, right? You're basically converting code into YAML. But the upside is for that is that workflow does that call for you. You don't have to worry about deploying that service anymore or running that service. So that's something you need to worry about. And also testing YAML. How do you test this YAML? It's not easy to unit test things like that. Debugging, testing, logging in workflows, it's not mature yet in the sense that there's no way to locally debug workflow, and there's no way to unit test these things. We are aware of this, and the engineering team will kind of provide some solutions on that. But as of today, the only way to test your workflow is basically just deploy it and see if it works, right? And that's not great for developer experience, and it's something that we want to improve as we go forward. With workflow, you lose a little bit of parallelism because right now workflows doesn't support parallel executions. Everything is run sequentially. It will support parallel executions very soon. But in the meantime, we had to do things sequentially, which means that we lost parallelism. So some things that could be done in parallel, now they were done in sequential, and that just affected our life. And then we lost a little bit of flexibility with eventing, right? With eventing, you can plug things in as you want, but with Orchestrator in the picture, you need to deploy the service and you need to configure your workflows service to basically plug the service into your as a new step, right? So that's losing a little bit of flexibility, but that's the whole point of workflows, right? You don't want the flexibility. You want to provide a little bit of kind of structure to your architecture, and that's why you use it. All right, so I think that's all I have to say. If you want to learn more about workflows, this is the link. If you want to do this workshop, we have 6 labs where we show you step by step how to build this app from beginning to the end. First, the event-driven way, using all the eventing stuff that I talked about. And in the last lab, we show you how to take that same app and convert it into Orchestrator using workflows. So if you're interested, this is the workshop. And then the code is all on GitHub, open source. So feel free to check it out. I will just stop here for now. I haven't checked the chat or anything like this, so I don't know if anyone has any questions. But if you have any questions, I'm happy to answer them right now.
Seems like there are no questions on chat.
Okay.
Let's see if somebody raises their hand and asks something. Matthias is applauding. Also Claudia.
Yeah, and also, I mean, if no questions today, but if you try something later and if you are stuck or have questions, you can always reach out to me on Twitter. I'll be happy to answer any questions afterwards as well.
Okay, since there are no more questions, I think I will close this session for today. And so, goodbye, everyone.
Cool. Thanks a lot, everyone, for listening. And yeah, have fun in the next meeting or so at DevOps Porto. Take care.
Some people saying thanks.